Welcome back to the Deep Dive. This is where we take the world's densest, most challenging source material, the stuff that really forms the backbone of modern knowledge, and we break it down,
So you, our listener, can walk away feeling incredibly well-informed.
maybe even ready to challenge a philosophy professor or two. Okay, let's unpack this.
Today's deep dive focuses squarely on one of the most successful frameworks in modern cognitive science and the philosophy of mind.
We're talking about functionalism.
Yes, and specifically when it's married to the representational theory of mind, or RTM. This is really the doctrine that currently dominates the conversation about what the mind is and how it works.
Our sources today are pulling from some really foundational texts in rationalist thought, the ones that systematically lay out functionalism's entire logical architecture.
And our mission, I think, is pretty clear.
We need to understand how this view emerged as, well, a better alternative to earlier materialist models.
And why it uses the language of computation. That's its core metaphor.
Right. And how it attempts to solve these old philosophical headaches, like the problem of circularity when you're trying to define mental states.
Crucially, we're also going to spend a good amount of time exploring its Achilles heel,
The big critiques.
the powerful, persistent critiques levied against it, particularly from these thought experiments about conscious experience, what philosophers call qualia.
So by the end of this, you will have a thorough grasp of the machinery of the mind as it's been conceived for, what, the last 70 years of serious intellectual inquiry?
Right.
Okay, so before functionalism really took hold, say in the 1960s, the leading scientific materialist theory was something called the identity theory.
Right.
And this theory was, it was incredibly straightforward. A mental state, like being in pain, was just identical to a specific physical state in the brain.
Often specified as a certain kind of neural activity. The famous example is C fiber firing in humans.
It seemed clean,
Yeah.
maybe a little too simple in hindsight.
It was pioneering work, for sure, dating back to figures like UT Place and JJC Smart in the 50s. But it ran into some pretty severe conceptual problems, and quickly.
So functionalism came along.
Yeah.
But it wasn't a retreat back to dualism, right? It wasn't saying the mind and body are two separate substances.
Not at all. It was a sophisticated pivot within materialist thinking. It allows that while minds are, of course, realized by material substances, the properties of the mind are not strictly material properties.
I have to stop you there because that's a really crucial distinction.
Yeah.
If it's compatible with materialism, how is it not just a materialist theory? Plain and simple.
It's because functionalism defines mental properties based on their role, not their stuff. It basically says the identity of this state is defined by what it does.
I see.
So whether the stuff doing that job is carbon-based neurons or silicon chips or even, hypothetically, some kind of ectoplasm, that's secondary. So while most functionalists are philosophical materialists, the theory itself is officially neutral on that.
It holds that mental states are multiply realizable.
Exactly, meaning they can, in principle, be realized by a huge variety of material or even immaterial bases. And that ambiguity is what protects it from the failures of the old identity theory.
And this leads us right to the core analogy, the computing machine.
It's no accident that the rise of functionalism perfectly coincided with the meteoric rise of computer science. It was a genuine intellectual breakthrough for the field.
The core insight being that when we talk about computation, we abstract away from the material substrate entirely.
We ignore the hardware.
Right.
Exactly. The functionalist asks you to consider the operation at its most abstract level. You can have two vastly different physical mechanisms performing the exact same computational operations. This is often the hardest leap for people to make when they first encounter this idea.
We can make it more concrete, though. Just look at the history. Think about Charles Babbage and his vision for the analytical engine back in the 19th century.
Right. Our sources describe it as this theoretical machine made of what? Brass gears, cylinders, levers?
A massive locomotive-sized piece of hardware, purely mechanical.
And then you contrast that with the vacuum tube machines of the mid-20th century, like ENAS, and then fast forward again to the microscopic silicon transistors that run our phones today.
The physical difference is just astronomical. Brass gears versus electron flow.
Yet, conceptually, when they calculate 2 plus 2, they are fundamentally on a computational par. One is obviously faster or cheaper, but they are performing the same kind of computation.
A computation defined by formal logical rules.
Precisely.
So if the same mathematical function can run on steam-powered brass or modern electricity, the function itself has to be distinct from whatever material is running it. This is the software-hardware distinction.
That's the analogy right there. The functionalist says, minds relate to their material embodiments, our brains, as computer programs, the software, relate to the physical devices, the hardware that they run on.
A computation isn't reducible to a transistor process.
No, the transistor process realizes the computation. It brings it into being.
Which means a mental state, like a specific thought, say, thinking about Vienna or a feeling like pain, is not identical to a specific brain process, like a pattern of C-fiber firing.
The brain process merely realizes that thought or feeling.
And this gives functionalism the weapon it used to dismantle the identity theory.
The concept of multiple realizability. If mental states are purely functional, they can be embodied in an endless array of systems. Our sources are very clear on this. They could be realized by human brains,
Or by the non-carbon-based biology of some complex Alpha Centaurian alien.
or by a massive hydraulic system, or even, if you believe in such things, by immaterial spirit stuff, as long as that stuff possesses the right functional architecture.
So the argument against identity theory is pretty simple then. If being in pain was C-fiber firing,
A type identity.
right, a type identity,
Yeah.
then any creature without C-fibers simply could not feel pain. And since an octopus clearly shows pain avoidance behavior, and its biology is completely different from ours.
It just seems wildly implausible that it doesn't experience pain. It's a kind of chauvinism, really.
Therefore, pain cannot be identified with C-fiber firing. Pain has to be a higher-level, abstract, functional state.
A state that can be shared, in principle, by any number of physical systems, provided they all perform the same causal job. That's the core flavor of functionalism. It's defined by functional identity, not material identity.
Okay, so that makes the shift from identity theory seem very logical, almost inevitable. But functionalism isn't just a clever analogy, is it? It actually defines a specific project for the cognitive scientist.
It does, yes. Functionalism frames the scientific investigation of the mind as a massive reverse engineering task.
So scientists are faced with the black box of human behavior.
Exactly. Their job is to observe the inputs, all the sensory data and the outputs, all the behavior, and then from that, hypothesize about the internal software, the architecture of the program that's mediating between them.
And this gives us what our sources call the levels of explanation.
Right. You have the neuroscientist and the material scientist who are working at the hardware level, analyzing the physical nature of the realization.
And then you have the psychologist, or the programmer, or the philosopher of mind.
And they're working at the higher software level, analyzing the causal structure, the program itself.
So they're explaining the same phenomena, but using different taxonomies, different ways of carving up the world.
Which is vital for applied fields. I mean, think of a troubleshooter, a physician or a clinical psychologist. They need to be fluent in both languages.
Because if a patient has a cognitive malfunction, a system crash,
It could be a software bug, a psychological or developmental issue, or it could be hardware defect, a physiological problem, a neural problem, like a tumor or a chemical imbalance.
we have to mention the legend here, right?
The origin
Of the term bug.
the Lieutenant Grace Hopper, yes.
As the story goes, she found that ENIAC, one of those early computers, had stopped working because a moth had literally gotten trapped in a relay.
A literal bug causing a hardware defect. But of course, in modern usage, a bug almost always means a flaw in the code, the software level.
Functionalism demands we respect both levels, even when a system malfunctions.
Absolutely. And that brings us to the deeper implication here, the functionalist ontology. Functionalism is committed to this idea that the world is layered.
That mental properties are distinct ontological properties from material ones.
Even though mental properties are realized by material ones, the failure of the identity theory for the functionalist was basically confusing these levels.
So, to use an example from the source, moving your arm in a certain way is a physical event,
Right.
but signaling a left turn, that's a functional property.
A property realized by that event. Signaling a left turn is not a kind of arm motion.
Because you could do it with a light, or a flag, or by shouting,
So the functional property can't be reduced to its physical realizer.
which gives us the formal definition. A functional property is one that an object has simply by virtue of satisfying a specific job description, a causal role.
The material composition, the stuff it's made of, is irrelevant to the identity of the property itself.
This is where the analogies in the source material really help to anchor the concept. Start with a simple one. Being a vice president. Let's say Wayne is the VP. He has that property purely because he satisfies a complex job description outlining his causal role in the corporate system. He supervises departments, reports to the CEO, and so on.
And that property, being a VP, is multiply realizable. The job could be filled by any person, regardless of their biology. Or in a sci-fi scenario, an advanced android or even a brilliantly trained chimpanzee, as long as it fulfills the functional criteria.
The property is abstracted from the individual occupant.
Exactly.
The same goes for an artifact like a clock. An object is a clock, not because it's made of brass or crystal or historically a burning candle. It's a clock because of what it does.
Its functional role is to reliably keep and display time. The material is irrelevant to that definition.
And moving to biology, we can talk about the eye.
A very complex functional role there
Yeah.
to extract specific structured information from light radiation and make that information available to the system it's a part of.
And it doesn't matter if it's the compound lens of a honeybee, the simple lens of a human, or a camera sensor in a robot, if it does that job.
It's functionally an eye.
The most common biological example, though, the one in our sources, figure 4.1, is the heart.
Right. It's defined functionally as the organ whose job is to circulate blood.
And the property of being a heart is realized by a specific lower-level biological configuration in humans. Let's call it configuration K.
But the functional property of being a heart is not identical to configuration K. It's the role that defines it.
So applying this framework to the mind, mental properties like being in pain are functional states.
What makes pain? Pain is not the specific neural configuration, the C fiber firing. It's occupation of the right sort of causal role within the whole system.
This is the crucial takeaway. Functionalism identifies the mental state with the functional role, the job description, the type, not the occupant, the specific realizer, the token.
It accepts token identity. This specific instance of my pain right now is this specific instance of C fiber firing in my brain.
But it fundamentally rejects type identity. The category pain is not the category C fiber firing.
And that distinction is what saved materialism from a simplistic reductionism. Now, functionalism's rejection of the identity theory, that's really only half the battle,
Right, because they were also equally committed to rejecting behaviorism.
which was the theory that tried to define mental states purely in terms of observable behavior.
The behaviorists really tried to analyze away the internal mind completely. They would say, to be in pain is just to be disposed to groan or to withdraw your hand or to seek relief.
They wanted to define everything in terms of observable input-output relations. No black box necessary.
But the functionalist critique here is, well, it's pretty devastating. It centers on what's called the circularity trap.
The behaviorists tried to define each mental state independently, but the problem is you simply cannot define the behavior for one mental state without mentioning other mental states.
Let's use the example from the source, eating a burger. If we try to define the disposition to, say, eat a Whopper,
You'll only do that if you're hungry and you believe the Whopper is edible and you don't believe you're allergic to it and you don't have some strict dietary rule against fast food.
the moment you introduce belief or desire or hunger,
You're introducing a network. Mental states are not islands. They're connected nodes in a complex causal flow chart. If you try to analyze the belief, the handle is hot, you have to invoke the desire not to be burned and the sensory input from the object.
this network approach is what we see in figure 4.2 with the pain example. It's so important. Pain is not just input hot handle leading to output withdraw hand,
No, it's the central node that causes the belief that the hand is burned,
which causes the desire for ointment.
which in turn causes the belief that the ointment is in the medicine chest, leading to the final behavior of walking to the chest.
The identity of pain is defined by this whole complex web of relations, both internal and external.
But this is where the circularity objection comes roaring back. If every state gets its definition from its relation to other states, how does any single state get defined in the first place?
It feels like you're defining A in terms of B, B in terms of C, and C back in terms of A. You're trapped in a loop.
The famous analogy for this is the community where everyone makes a living by taking in someone else's washing. It's perfectly balanced internally, but there's no money coming in from the outside.
So how do functionalists break out of this circle?
They deploy a really sophisticated strategy known as the total functional description, which was heavily influenced by the philosopher David Lewis.
The trick is to stop trying to define mental states one by one.
Exactly.
Oh.
Instead, you have to characterize the causal network as a whole system, defined only by its ultimate sensory inputs and behavioral outputs.
Okay, so we take the entire conceptual flow chart of the human mind with its millions of nodes, and we basically erase all the mental labels we were using. Pain, desire, belief, they all go.
Gone. We replace pain state with a neutral placeholder, let's call it F1. We replace belief that the handle is hot with F2, and so on.
Until we have this incredibly complex map of F nodes, anchored only at the very beginning by sensory inputs, and at the very end by behavioral outputs, like we see in Figure 4.3.
That's the total functional description of the system's causal architecture.
And then once we've done that, once we've defined the whole system holistically, we can go back and define pain.
Not by what it's made of, but by the space it occupies on the map. Pain is now defined as a state that occupies the place of F1 in any system that possesses the causal architecture exhibited by the total functional system.
It's a holistic solution. It reminds me of defining points in geometry.
That's a great analogy. No single point in a coordinate system has an intrinsic definition on its own. But once the system, the grid, is established through all its mathematical relations, every individual point can be specified without any circularity.
You define the whole game before you define the positions of the individual pieces.
Exactly.
And that is a really remarkable logical maneuver. It's what separates functionalism from behaviorism for good.
Yes, because even though the whole system is anchored to input and output, the functionalist takes those F nodes, F1, F2, F3, to designate genuine, causally efficacious internal states of the system.
Whereas a behaviorist, even if they use that same map just to predict actions, would see F1 as just an abstract disposition, a shorthand.
For the functionalist, F1 is real internal machinery. It's the thing that causes the subsequent states and behaviors. And that machinery, the specific program that fills that causal role, is what we need to look at next.
So functionalism gives us the general blueprint. Minds are these complex systems defined by causal roles, realized by physical stuff. But what's the specific structure of that software?
Right. How do we actually model the architecture of belief and desire?
How does it work?
This is where we transition to the representational theory of mind, or RTM, most famously defended by the philosopher Jerry Fodor.
Okay, so RTM provides the specific computational framework for how that total functional system actually operates on the inside.
And to do that, RTM requires us to postulate internal mental representations. Fodor suggests we imagine the mind as containing, storage areas. He calls them a belief box and a desire box.
Which we see illustrated in figures 4.4 and 4.5. And these boxes contain symbols.
So when you form a belief, for example, the window is open, a symbol expressing that proposition is physically deposited or instantiated in your belief box.
And when you desire for the window to be closed, a corresponding symbol is in your desire box.
And then the computational architecture processes the configuration of those symbols, which leads to the appropriate action, in this case, the behavior of closing the window.
So this implies that our internal thoughts, our whole mental life, must operate using a kind of internal language, a biologically fixed code that acts as these mental symbols.
Fodor famously called this the language of thought, or LOT. It's essentially the mind's internal machine code. Thoughts are just sentences or symbol structures in this language.
And if RTM is the right description of our mental architecture, it successfully accounts for the systematic and productive nature of human thought.
Exactly. Just like a natural language, you can combine symbols in new ways to generate novel beliefs and desires you've never had before.
Okay, but here's the massive problem that RTM needs to solve right away. If the mind is just a symbol manipulator, how can it manipulate those symbols without understanding what they mean? We don't want to fall back into the same circularity we just escaped.
This is where we bring in the key functionalist concept of the semantic engine, an idea popularized by John Hogland.
A semantic engine.
It's a device designed to manipulate symbols based purely on their formal and syntactic properties, that is, their shape, their structure, their position. It operates completely blind to meaning, to semantics.
But the magic of the semantic engine is that it's engineered so that this blind formal manipulation coincides perfectly with the manipulation someone who did understand the symbols would perform.
We rely on these engines constantly. A computer operates on patterns of magnetic deflections or electrical charges, uninterpreted symbols, but it manipulates them using rules so precise that the result is logically and semantically meaningful to us.
When your calculator adds 2 plus 2, it's just following rules about symbol shapes, not rules about the concept of two-ness.
The best philosophical example is rules of inference in logic. Let's take modus ponens.
If P implies Q and P is true, then Q must be true.
The rule itself is purely syntactic. It just says, If you see a horseshoe symbol between two letters, and you also see the first letter all by itself, you are permitted to write down the second letter.
It's a mechanical process based only on the symbol's appearance and their arrangement.
Yet, when we plug in semantic content, it's profoundly meaningful. If it's raining, I'll need an umbrella. It is raining, therefore I'll need an umbrella.
So the mind, as a semantic engine, operates on the shape of the thought symbols in the language of thought and churns out a semantically sound conclusion.
All without needing a little conscious agent inside the head to read the symbols.
And this maneuver is the definitive functionalist solution to the dreaded homunculus problem.
Yes. If the mind manipulates symbols and manipulation requires understanding, then you need a sentence understander inside the head, a little person, a homunculus.
And then you'd have to explain how his mind works and so on forever.
Infinite regress. The semantic engine structure solves this by showing that the manipulation itself is non-intelligent. It functions just as though it understood, but the mechanism is purely syntactic.
It's important to stress, though, that these mental symbols in the brain are not like tiny visible letters.
Absolutely not. They are abstract structures. Our sources remind us they might involve subtle electrical states or complex neural connectivity patterns. You can't just look at a brain and read the language of thought.
It's like trying to decode a complex musical score just by examining the microscopic grooves of a vinyl record.
The physical embodiment is totally opaque to the higher-level functional definition. So RTM and the semantic engine concept they're really elegant solutions. They provide a mechanical explanation for how intelligence can emerge from non-intelligent processes.
But that elegance is precisely what John Searle targeted in his famous, and I have to say fiercely debated, critique.
The Chinese room thought experiment.
And this thought experiment is just designed to blow up the functionalist claim that manipulating symbols by syntax alone is the same thing as genuine understanding. It kind of operationalizes a Turing test in a very personal way.
The setup is everything here. Imagine you, the listener, are placed in a locked room. You do not speak or read a single character of Chinese. To you, it's all just meaningless squiggles.
But you have a massive instruction manual, the computational program, and baskets full of these Chinese characters.
Input squiggles, which are questions, are passed into the room. You just follow the manual's rules perfectly. If you see input sequence A, you match it to output sequence B from the basket. These are purely formal, shape-based rules.
You have absolutely no idea what any of these squiggles mean.
But outside the room, native Chinese speakers are passing in sophisticated questions and receiving coherent, grammatically perfect answers that you, the operator, have produced.
So to the outside observer, the system, the room, is passing the Turing test with flying colors. They would have to conclude the system understands Chinese.
But here's Searle's punchline. He says, you, the person inside performing the function, possess zero understanding of Chinese whatsoever.
You're functioning as a perfect semantic engine, manipulating symbols based on syntax alone, but meaning is completely absent from the operation.
Therefore, Searle argues, the computational manipulation of symbols only simulates understanding. It is not the real thing. Functional organization is not sufficient for genuine mental states like semantic understanding. Something crucial is missing.
Now, functionalists obviously couldn't just let this stand. They've offered several rebuttals over the years.
The most common and probably most powerful response is what's known as the systems reply. The systems reply argues that Searle is misdirecting our attention. He's focusing on the wrong component. Yes, the person inside the room, the CPU, the individual realizer, does not understand Chinese. But the system as a whole, which includes the person, the manual, the program, the basket of characters, the memory, and the room itself, the overall architecture, that entire system performs the function of understanding Chinese.
So the system understands, even if its component operator does not.
That's the argument.
That is a clever move, but it still feels like it's avoiding the core intuition, doesn't it? If the entire nation of China were organized to do the job of that one person, would we really say the nation itself understands Chinese? It still feels like all we have are cogs in a machine performing a mindless function.
And that skepticism leads us to the deeper inherent weakness that RTM has to address, the problem of original meaning, semantics.
Right. If the symbols in the language of thought are manipulated blindly, syntactically, where does their meaning actually come from?
Well, we've already established that the meaning can't be intrinsic to the symbol itself.
And it can't be assigned by the thinker, because that would require the thinker to already have meaningful thoughts, which is circular.
And we know that symbols in a normal computer have what's called derivative meaning. They mean bananas, because a human programmer intended them to mean bananas.
But our own thoughts can't get their meaning from an external agent. They have to possess original meaning.
So RTM proponents are forced to advance a pretty sophisticated, externally grounded solution. It's a broadly causal account of semantics.
A causal account.
Yes, the idea is that the meaning of a symbol in the language of thought must be fixed by the context of the thinker and their relationship to the world. An internal expression designates bananas because its presence is reliably causally evoked by the presence of bananas in the external world.
And its presence causes behaviors appropriate to bananas.
Right. The meaning is anchored to reality through this structured, highly complex web of reliable causal links between the internal symbol and the external thing it refers to. This context-dependent causal chain is what gives the uninterpreted symbol its semantics.
Which allows the semantic engine to genuinely operate on meanings, even while being blind to them internally.
That's the hope, anyway.
So this moves us from the internal architecture of the mind to functionalism's really sweeping metaphysical claims about reality itself.
It does. Functionalism provides the definitive modern rationale for the layered view of the world.
This perspective that reality contains these distinct levels of properties, and they're governed by distinct levels of causal laws.
You have physics at the bottom, then chemistry, then biology, then psychology, and finally sociology at the top. Higher order things, like minds, fit into the material world without just being reduced to it.
And this whole structure is the ultimate vindication of the special sciences.
Sciences like psychology, economics, or biology. These sciences use their own taxonomies, their own ways of classifying reality that are just not reducible to the categories of fundamental physics.
And why does that reduction fail? We keep coming back to this.
We do. It's multiple realizability again. Because a higher level property, like being a computer, can be realized by a potentially infinite number of lower level physical configurations.
Brass, silicon, hydraulic devices.
You can't define that higher level category using a finite, exhaustive list of physical properties.
So a psychologist can't say being in pain is either physical state A or physical state B or C and so on, because that list would be endless. The very concept of pain transcends any specific material it's made of.
Which means that from the viewpoint of physics, the categories used by the higher sciences look completely arbitrary.
The source material uses this fantastic chess analogy.
It's perfect. If a physicist tried to write down the fundamental, exceptionless laws governing quarks and electrons, they would never, ever be able to generalize about the behavior of a knight or a pawn.
Because the functional properties of a pawn moving one step forward, capturing diagonally, are totally unprincipled and contrived from the perspective of particle physics.
The patterns and regularities only appear at the higher level of analysis, at the level of the game itself.
Therefore, the special sciences are not just temporary conveniences waiting for physics to catch up and explain everything.
No, they are necessary. They're necessary because they capture genuine generalizations that hold true at their specific level of abstraction. Generalizations that would be utterly lost if we limited ourselves to lower-level explanations.
Like, if you describe two different machines running the same program, one hydraulic and one silicon, purely in terms of water pressure and electron flow.
You completely miss the generalization that both systems are doing sums, that truth only exists at the computational level.
And this is Fodor's key argument, that these higher-level categories, desire, belief, being, and pain, they designate genuine properties.
Because they figure in genuine causal laws formulated by the special sciences. A property is real if it makes a causal difference in the world, and beliefs and desires certainly do that.
Okay, but this brings us to a really critical and I think often overlooked aspect of this layered ontology, the nature of those higher-level laws.
They are almost always ceteris paribus laws.
Meaning they hold only other things being equal.
Right. Fundamental physics laws, like the law of gravity, are generally taken to be exceptionless. But laws in psychology or economics or even neurobiology are hedged. They're approximate. They describe what should happen under idealized conditions.
Let's use the psychological law we talked about earlier. If an agent S wants $6 and believes it's needed to get $6, then S will form a desire for yes.
So if you want coffee and you believe grinding the beans is necessary, you'll form the desire to grind the beans. Seems simple enough.
But that law is fragile.
It's incredibly vulnerable to intervention from lower levels. If, just as you're forming that desire to grind the beans, a sudden localized burst of neural activity, maybe a tiny seizure, or the physiological shock from a piece of falling plaster hitting your head knocks you
The
unconscious,
psychological law is interrupted. The desire never translates into action.
and the psychological law has to remain silent about those molecular events. If it had to account for every possible way neural activity could fail, it would cease to be a psychological law.
So the laws of the special sciences are genuinely explanatory, but they are fundamentally hedged truths.
That's the metaphysical price you pay for acknowledging the layered reality that functionalism requires. Okay, so we've established functionalism's success in accounting for function, explanation, and the structure of reality. But now we have to turn to the point of, well, existential crisis for the theory.
The problem of qualia.
The qualitative aspect of experience. This is what critics argue. Functionalism fundamentally misses or ignores.
It's the raw, subjective, intrinsic what it's like of a state. The subjective bitterness of coffee, the burning, throbbing feel of a headache, the unique redness of a sunset.
Functionalism can explain the job of pain, but does it explain the actual feeling of pain?
And the functionalist is really obliged to argue that the feeling, that qualitative dimension, is not what makes pain a pain.
Right. For a functionalist, what matters is the causal role. They might grant that pain has a characteristic feel, sure, but that feel is just an accompaniment, not the essential property.
If you define pain purely by its role in prompting withdrawal and the formation of aversion beliefs, then the feeling itself is peripheral.
But that separation immediately seems to violate our deepest intuition about what consciousness is.
Because if the functional structure is all that matters, then it raises the possibility of creatures that possess the structure without the feel.
And this is the philosophical zombie.
The zombie thought experiment. It's probably the most powerful tool used against functionalism.
A philosophical zombie is a hypothetical creature that is, by definition, functionally identical to a human being. It has the exact same internal architecture, inputs, and outputs.
It recoils when it's burned, it shouts, ouch, it complains of a blinding headache and goes to find aspirin. Every single F1, F2, F3 node in its functional map is perfectly realized.
And this is the whole point, the zombie entirely lacks any inner qualitative feel, any conscious experience.
There's no inside. The lights are off. It's a mindless automaton that perfectly simulates consciousness, but experiences nothing.
And the implication for functionalism is devastating, if such a creature is even logically possible.
It means that functional structure is not sufficient for consciousness. Function explains behavior, but it doesn't explain qualia.
And if consciousness is necessary for having a mind, and functionalism leaves consciousness out, then functionalism is an incomplete theory of the mind. Period.
So how do functionalists get out of this? How do they navigate this existential crisis? Our sources lay out three major responses, and each one forces the theory into an even more radical position.
Okay, so response one. Deny that zombies are possible.
Just say they can't exist.
Right. This group argues that the complexity required for true functional identity automatically guarantees consciousness. To be functionally identical to a human means having an immensely complex architecture that can introspect, reflect on pain, form beliefs about your own experiences, empathize with others.
And they argue that this level of self-monitoring and information processing just is consciousness.
Exactly. Therefore, a functionally identical zombie is impossible. If you build the machine right, the lights just turn on.
But that feels like it's just rephrasing the problem, doesn't it? It requires this unproven assumption that highly complex computation equals subjective experience. The zombie proponent just insists that you could copy the functional complexity perfectly without that crucial ingredient.
Which leads to the second strategy, the famously counterintuitive move: bite the bullet.
Just accept the crazy consequences.
These functionalists accept the implication of the zombie challenge. They argue that functionalism is such a successful theory otherwise. It explains everything except qualia, that we should just conclude that qualia or consciousness are real, but they're strictly inessential accompaniments.
A non-functional side effect of complex organization.
Exactly. And this biting the bullet response is often illustrated by Ned Block's famous thought experiment.
The China brain, or the China nation.
Imagine taking the entire population of China, giving every person a walkie-talkie, and assigning them a role, an F node, in a system designed to functionally mirror the entire causal architecture of a single human mind.
One person is F1, pain. Another is F2, belief that the handle is hot. They all coordinate inputs and outputs with the external world based on instructions.
The system as a whole would receive inputs and produce human-like outputs. It would pass the Turing test perfectly, though it would operate excruciatingly slowly. A single thought might take a year.
And functionalism insists that this massive, slow, telephonically linked system must be a mind and perhaps even conscious because it replicates the function.
For most people, the intuition that the entire nation suddenly becomes a conscious being is just wildly implausible. But the bullet biter accepts this as the unavoidable, strange consequence of following the functional logic to its extreme.
Okay, so what's the last strategy? It seems like they're running out of options.
The final strategy is maybe the most intellectually subtle, response 3. Dispense with qualia entirely.
Just get rid of them.
Essentially, yes. This aims to eliminate the need for non-functional properties by arguing that we are just confused about what the qualitative aspects of experience even are.
How does that work?
This strategy asks us to rigorously distinguish between the qualities of an experience and the qualities that are represented by that experience.
So when you look at a green tree,
The experience itself, the neurological event happening in your brain, is not green or tall. The intrinsic properties of the experience are just neurological properties, which functionalism can handle just fine.
but the critic insists, what about the subjective greenness we perceive? Or the throbbing feel of a bad headache? Those seem like inherently qualitative, non-functional features of the experience itself.
And the functionalist countermove is to argue that these are qualities we represent objects or bodily occurrences as having, not qualities that are intrinsic to the experience.
So when you feel a throbbing pain in your toe,
You are representing an aversive bodily occurrence as throbbing. They point out that when we actually examine the toe, or the specific neural activity in the brain, nothing is physically throbbing in that way.
so throbbing is a quality that is mistakenly or maybe necessarily attributed to the experience. It's a feature of the representation, not the experience itself.
And if we can account for the experience entirely in terms of functional representation, how the system processes, categorizes, and reacts to that aversive signal, then the need for a non-functional, mysterious qualitative residue for qualia just disappears entirely.
That's a powerful strategy, but opponents would say it's just a failure to meet the problem head on. It's basically telling the conscious agent, you are wrong about what it's like to be you.
It is. But for these functionalists, the theoretical cost of accepting mysterious non-functional qualia is much higher than the intuitive cost of denying them. #tagged outro outro.
So we have journeyed through the full architecture of functionalism and the representational theory of mind. We saw its core victory, really, in the concept of multiple realizability.
Which allowed the philosophy of mind to escape the reductive pitfalls of the old identity theory, while still maintaining a commitment to a science-compatible material realization of the mind.
We established that RTM provides the specific model, the mind, as a semantic engine manipulating these uninterpreted symbols in a language of thought.
And thereby offering a mechanical, non-circular solution to the homunculus problem, and giving specific content to those abstract functional roles.
Yet we cannot ignore the deeply compelling critiques. Searle's Chinese Room insists that syntactic manipulation can never capture true understanding.
And the logical possibility of the philosophical zombie suggests that function is not sufficient for consciousness.
Which forces functionalists into these extreme positions, whether it's denying the possibility of the zombie or just trying to explain away the subjective feel of experience entirely.
Fundamentally, though, functionalism provides this powerful metaphysical rationale for the existence of higher-level sciences like psychology. It shows that these sciences capture genuinely causal laws and generalizations about the world.
Truths that fundamental physics would miss entirely.
But we noted the crucial caveat.
That those genuine higher-level truths are fundamentally hedged. They apply only ceteris paribus, other things being equal. The laws of physics are exceptionless. The laws of desire formation are vulnerable to a slab of falling plaster.
So we'll leave you with this provocative thought to mull over. If the specialized categories of psychology are only justified because they capture these important ceteris paribus causal laws, what's the ultimate consequence of accepting a science of the mind whose highest truths are inherently contingent and contain exceptions?
Do we rely on these higher-level hedged laws that can always be interrupted by lower-level physical events, for our understanding of human agency, of personal responsibility, or even free will? Is a law that is constantly vulnerable to exception still a foundational truth?
Something to keep turning over until our next deep dive. Thanks for listening.